Hello, Data Science Systems, DS 2002. Neil McGee here with the second lecture for the week. And this one is a bit more technical and a bit more complex. And as we talked about in class, I thought the video format, at least as I would want to learn it, this would be more ideal than just one shot in the classroom. So I like the fact that you can watch this over again, you can pause it, you can go back a little bit, repeat things, and so on. I would encourage you to take notes on this. These slides will be posted in Canvas, but take notes to kind of make sense of things yourself. And I'll just try to split this into two halves, roughly halves. One is just an overview lecture, just like 6 or 7 or 8 slides long, talking about the components and the things going into building virtual machines, we call them, virtual computers in the cloud. And then the second half will be actually doing it. And I'll walk you through it, and I would like you to pause the video at certain points and repeat what I just did. Or if you have 2 monitors, or if you use spaces like in a Mac where you can switch different desktops, and you can do that in Windows as well, you could flip over while you hear me, and you could follow along in AWS yourself. So let's dive in. I want to talk about virtual machines, just how we build them, some of the options and choices that go into to turning one on. And then a couple of just kind of useful things to know about. Even if you don't put them to use right away, it's useful to know about as you work deeper in the area. So let's just dive right in. When you think about an EC2 instance, and again, this could be the same in Azure or Google Compute Platform or so on. These are all pretty much familiar options. You have sort of these ingredients, these things that go into assembling it. You could think of them as ingredients, you can think of them as options or choices. And so I just want to talk through, for the specific AWS context, talk through what these options are in no particular order. So the first is an AMI, and I'll describe a little bit more about that in a second, but an AMI is an Amazon machine image. And you can think of it like a it's almost like code in a repository in GitHub, where you have the code and you can take that code and now build and launch something based on that code. It's sort of a frozen in time image of a computer that someone has assembled with an operating system and these sorts of packages of software and this sort of configuration. And all of these specific little setups that have all gone into one particular computing instance, and then they create an image from it. And the image is sort of like a perfect version of it that then we could clone, and we could do 1,000 of them, and they would all be exactly the same because they're all based on that exact machine image. So some of the common AMIs we use are like Windows 2022 Server, or Linux, Red Hat Linux version 9.11 or something like that, or Ubuntu Linux, or Mac OS, whatever, Sierra. A machine image has essentially an operating system, but it also might come with some custom software or some software that you even pay for. Second choice is an instance type, and we'll look at that in another slide in just a second. And that just means, what resources should it have in terms of CPU and memory? Should this be a really, really strong server that can crunch a lot of data and do a lot of computing on its own, or is it kind of smaller and lightweight and I want to run 10 of them? It's choices like that. That also impacts network speed, how fast does this thing connect to the Amazon networks, and so on. Does it have GPUs, other options like that? But it's all about resources. Third is quantity. Do you want 1 of these? Do you want 10? Do you want 50? And so on. And that's just a simple question. We're not going to really worry about this. This is something in CS 4740 we would talk a lot about, is sort of the network placement of this computer. Should it be in a different availability zone from another server that we have running, so that they kind of, so that we have a little fault tolerance, and there, if we have an outage, it's likely that not both of them will go down. We're not going to worry about that so much here. You're going to run it in a VPC, but you're not going to have to worry about any details. The VPC is a virtual private cloud. It's like your account. It's your networking space within your account. An IAM role, we are going to use that a little bit, and this is pretty neat. They didn't have this originally, and it came around, 2012, 2013. where you could suddenly give permissions for an EC2 instance to have access to other things within your AWS account. And really the classic example, and the one that we'll use for the hands-on today, is giving your EC2 instance permission to talk to S3 buckets. By default, your server, your instance is just doing its own thing. It doesn't have any access to talk to other AWS services like you do. And so the IAM role is a way that you can sort of delegate permissions to that computer. And that way you don't have to take your access key and your secret key. You don't have to put them into this computer. That would be pretty risky, actually. So this is a nice way that you can actually give very specific permissions to say, okay, this computer can talk to this S3 bucket, and it can talk to this database, and it can do the following things, and nothing else. So it's a nice granular way of granting permissions. Another option is how closely do you want to monitor this? Do you want to really watch its CPU and memory usage and so on? Or do you want any alerts if it were to go down and so on? We'll touch on this a little bit, and this is one of those powerful options to know about for the future, is user data. And this is a term, and I mentioned bootstrapping in class. Bootstrapping works with user data as a way of injecting a set of commands into the computer when it is created. And it's important to know that doesn't happen every time you reboot the machine. It doesn't reissue those commands. It just does it just the very first time you create that computer. And so it might be something like, hey, install Git and install JQ and then install the AWS command lines and go grab the following script and run it, and grab the following Git repository and clone it, and so on. So it's a way of kind of having your computer set itself up when you create it, which is great because that means you don't have to shell into the computer and update and install those things yourself. Another choice, storage. How big a storage volume do you want? Do you want 12 gigs? Do you want 100 gigs? Do you want a second hard drive, and so on? We won't touch on this a lot, but a security group is sort of a networking filter for your computer that says, okay, what do you want to run some service on this computer? And if so, we need to open a specific port for that service. And the really common example of that is, what if you wanted to run a web server or an API that runs on the web? What if you wanted to run that on this computer? You would want port 80 open, and you would probably want port 80 open to the whole world. So it's a really common scenario, very, very common scenario. And another really common scenario is, well, we're going to SSH, we're going to connect and shell into this computer and use the terminal inside of these servers, and that requires port 22. And you would not want port 22 open to the whole world, because you're just kind of inviting hackers at that point to say, hey, come try to knock down my server and come try to invade it. And you don't want to open up that to the world. You want to open it up to a very small pool of addresses. And then finally, a user key. And you've actually already got a user key. When we set up our GitHub accounts and I had you use SSH keygen, you created a keypair, a private key and a public key. And so you're going to use that private key as a way to sign into the server. We don't use usernames and passwords in EC2. We use SSH keys. That's a much stronger way to authenticate. It's a way of signing into the server when you need to talk to it. Okay, so those are the basic ingredients to launch an instance. And I think you'll see how these kind of come together as we do it in a hands-on sort of way. I did want to touch on these machine images, these AMIs, really, places where you could get them. And again, this is a choice of operating system, and I should update this list. Mac is now an option. So you can Linux, Windows, Mac OS, all the main distributions. And Amazon has a base set of these. They're really common ones. I bet 90% of all instances are just launched from these sorts of base AMIs. The marketplace is a place where you can go and actually, some of them are free and some of them cost money. You can get a very custom, very specialized machine image to do something really special. Maybe that's already got some software loaded into it. Maybe it's got a TensorFlow and PyTorch and some deep learning, machine learning sorts of tools already installed. That would be really super useful. Maybe it's got some product by a vendor that you need access to. So that you can find all that in the marketplace. There's the community AMIs, which you and I could actually contribute to. We can create our own, and I'll just go ahead and put that up. You can build your own AMI using a variety of different means. The easiest way is you just you use a base AMI over here, you install a bunch of things, you customize it just the way you want, and then you can save that instance as an image, and then you could share it with the community. The thing about the community is, it's sort of like Reddit or something, is you don't exactly know how safe any one of these are. It's not like AWS can security check every single one of them and kind of see if they're really clean and if they don't have any, backdoors or any sort of scammy software running on them. So you have to use that with a grain of salt. It might be good for testing, but I wouldn't really want to run something for real out of the community. But those are the places you can find AMIs, and I'll show you the most common place when we build. Next is instance types. And I just want you to appreciate sort of the choice, the realm of choices here. And there's some sort of families and groupings of them. You can get something super, super tiny and small. So a T2 Nano comes with one virtual CPU and a half a gig of RAM. So just a half a gig of memory, very small. This is like Raspberry Pi sized. And notice this, and this is not a typo. This is just a little over a half a cent an hour for this tiny little compute instance. And it can't do much. You can't run anything heavy duty on it. But it could certainly stay up and running and do tasks for you on a schedule if you needed, and so on. And then there's a whole realm of other things. Another option is this XE132X large. It's got 128 cores. Look at that, 4 terabytes of memory. And it costs nearly $27 an hour to run. So this is this huge, huge instance which could do a lot of computing. What I want you to, I think, appreciate is the difference in capacity between the two of these. Definitely notice the difference in pricing between the two of these. And know that if you leave something, first of all, if you create something like this and you leave it running, you're going to have a very large bill very soon. 24 hours of this is several $100s. So beware. Those are, and this has some GPUs and so on in it. There are some instance type families or classes. There's a couple more that I didn't list here just because they're so unique. The T class, like that T2 that we saw, it's what we call a burstable class. It can actually sort of burst above its specific resources for little periods of time. The M class is generalized. That's probably the most common for sort of real computing, normal computing, I should say. It's a balance between memory and CPU. The X and R series have more memory to them, whereas the C class has more compute, more CPU. So CPU optimized, and this is memory optimized. The P, G, and F, these are GPU classes for doing like deep learning, AI, machine learning, large language models, and so on, would want to run on one of these. And then here are these I, D, and H classes that are storage optimized. So they have really, really fast networking. They have even faster than this now. Incredibly high IOPS and really massive local storage volumes. So these are all choices you would make as you're looking to build something. Each one of these classes and families have all their different tiers of sizes available within them. Each one of those has its own specific configurations and pricing. So you'd want to research that closely before you spin something up. AWS does you a favor that some of these large, super high resource computers, you can't just turn them on if you want to, or you can't create more than one. They put a limit on these by default just so you can't accidentally create 20 of these D class or something like that. So you'd have to ask for permission to get more if you needed more. Next, bootstrapping. And this is where we use a feature called user data to inject a bootstrapping script into our instance. And these scripts can be insanely elaborate, very fancy, very, very, very granular. And I'll put this slide up here just to run through it quickly. We're not going to do a lot of this. This is something we do a lot more in Systems 2, to sort of prepare an instance for us automatically. When you think about a Netflix using EC2 every night, tens of thousands of computers, they're going to have their own custom AMI that they use, of course, but there's probably some little scripting that runs every time one of these computers is built, so that it checks in and says, hey, I'm ready for service, or hey, I need to grab the latest version, the very latest version of this particular file, and I need to pull it down, and I need to run some command and then check in before I can start being used by the public. Things like that are really, really common. So what I want you to appreciate is it's like a shell script that runs when you create the instance. And you'll see it's going to look just like a bash script. It's really nothing so fancy. There's other languages you can write them in, but bash is one of the most common. As I said before, it doesn't run when you reboot it. It runs as if it were root. So sudo is the super doer, the sudo su, the super user. So it runs with absolute privileges. It can install anything you want or run anything. A really important feature is that it's non-interactive, which means it doesn't sit there and give you a prompt to say, would you like to install this package? Y or N, yes or no. You're not there to click yes or no. It has to do it on its own. So it has to have explicit permissions and instructions of what to do. It's great for updating the software on the instance, just for grabbing those last little updates that might be available, installing software and so on. And like I said, it's good for checking in once it's ready. And for elaborate scenarios where you maybe need a fleet of 5 or 10 or 50 computers, you want them checking in to say, okay, I've finished setting myself up and now I'm ready to do some work. And I say useful up to a point because honestly, if you're installing tons and tons of software, if the bootstrapping is taking an hour to complete, then this is not the right way to go. You'd want to build an AMI at that point that has a lot of your software already built and loaded into it. And you can do that on a frequent schedule. You could automate that AMI creation if you wanted to. The bootstrapping is just useful for quick, light things that you need right at the last minute for this thing to get ready. And you'll see an example of this in our hands-on activity. This is, it doesn't quite look like this anymore. The page has just gotten updated by the design team at AWS. But these are some of the options when you're using the web console to create an instance. And I just wanted to show you down under advanced details, this is where you would put a bootstrapping script. And if you're familiar with this, these are giving absolute paths to yum, and we'll talk about yum. Yum update, and I'm giving it the Y flag to say, this is non-interactive, so it says yes to any questions that should come up. I'm installing Git and Python 3 and Python 3 dev and Python 3 pip and NFS utilities and so on, and then install some pip commands, bodo and pandas and requests and so on. So this is a very bashy looking sort of bootstrapping script, but that's just something you can add right in the web interface as you're building an instance. And then finally, there's 3 little examples of this. This is the example from before. It's a bash script. There's the shebang, and it's just got 4 lines. You can also use this language called cloud config. This is sort of more of a YAML language, and you can say, hey, I want these packages installed, and I want you to run these following commands. And these should look a little familiar to you, at least as a command goes. Here's a user mod, add this person to a group. Here's a change ownership mode, add this user and so on. Here's some find commands. Here's an echo command and so on. And then here's another, this is the mode I like actually. It's a simple little bash script which says, hey, bash, use the curl feature and go fetch this code out here, which I manage in GitHub, and then run it as a script. And so I actually don't have to put I don't have to put tons and tons of lines in here. I can just manage this script somewhere else in GitHub or someplace, and then just say, hey, grab that script and execute it, run it against bash. And then that way I don't have to always embed my long code in the bootstrapping. I can just manage it out here. Okay, so that's it for now. Let's shift over into the AWS Management Console. And And if you have the terminal available, whether you're in AWS Academy, you can use that built-in terminal in the screen. We're going to use that as well. But the AWS console and then the terminal, and we're going to build instances using both of those methods in some hands-on activities next. All right, hang on. Be right back. Okay, welcome back. So I have signed into the AWS Academy page into our Learner Lab, and I've gone ahead and started an AWS session. It's right here, and I told it to start the lab. We're 12 minutes in already. And I've pulled up the AWS details page. The next thing I did, as I showed you, is to go to the download URL, and that gives you a little text file like this one with this very, very long URL. And I took that and I signed into AWS using the single sign-on. So AWS Academy just passed me seamlessly right into the console. And I want to work with the console first, and we'll just get used to creating some instances. And I kind of have the goal that we'll create and delete, 4, 5, 6 instances here in the course of this lecture. So from the search box at the top, I want you to search for EC2. Should be the top instance, and you can click on the little star if you want to put it up in your toolbar right up here. That's great. And then click into the service. And one thing that we need between every session, and you don't do this very often, but you've got to do it at least once, is to create a key pair. So click into key pairs down here under networking and security on the left. And notice you've already got a key. There's already one here. And if we go back to the Learner Lab, you'll see hey, they've already got a key created for us, and this is how you can download it. You can see it. You can download the PEM file. That's what you'd want for Git Bash and for Mac OS. And there's another Windows program called PuTTY that needs a PPK format of the same file. But that's how you could get the key. You can see it actually here in the, embedded into the terminal here in the Learner Lab. There's the private key. But you and I already have a key pair, and I'd like to actually kind of use that. So shift over to your terminal, and if you go to your cd, /.ssh, your hidden SSH directory, you'll see this key pair that we created to authenticate to GitHub in the second week of class. So we don't need to create another key pair. We have a key pair. Remember that this is the private key. ID RS8, that's the default name, and the public version of it is right here. And I'd like you to cat out the public version. This is actually one line long. It's just a really long line. And highlight the whole thing and copy it. And then we're going to bring this and we're going to import a key into EC2. And so if you were working in a new account, you didn't have any keys, and you just want to create one, you can actually have AWS will create one for you. And when you create it, it downloads the private half down to your computer, and it keeps the public half up there. We don't want to do that. We want to import a key pair. So go to Actions, Import Key Pair. I'm just going to call it ID RSA. And I'm going to paste the contents right down here. I don't need any tags or anything like that. I'm just going to import it right like that. And now I have two key pairs. You can have multiple, and you can delete these and change them out every now and then and so on. But we now have two keys that we could use as we create an instance. And you can never create an instance without specifying one key because there has to be a way for you to sign in and use this thing. So that's the first step, is importing your key. And from now on, we're going to use this ID RSA as a way of signing in to our instances, authenticating, shelling into our instances when we do that. Let me clear that page. We'll come back in a second. So now you can go over to Instances in the upper left, and I'm going to check my region here to make sure that I'm in Northern Virginia. There's all these other regions. Sometimes they'll shove you into Ohio by default, so make sure you're in Northern Virginia. And we're going to launch an instance. And this is just sort of a simple series of screens that we're going to walk through. Actually, no, they've consolidated all the way down to one. So over here, we can see the number of instances. Yep, we want one. Let's go ahead and give this a name, test 1. And that's great. We're already 2 pieces in, quantity and a name. Now comes the AMI part, the Amazon Machine Image, which is basically, hey, what operating system do you want to use here? We're going to use Amazon Linux. This is a Red Hat CentOS flavor of Linux, so it's a pretty common distribution. It's something Amazon's kind of tweaked a little bit. We're going to leave that just as it is. We're going to use the 64-bit architecture in x86 format. That's great. We're going to go to our instance type, and you can see here all the different versions that are available. C5D extra large, C5N9 extra large. You can look, this has got 36 cores, 96 gigs of memory. It's current generation. It gives you your pricing and everything like that. But I'm going to go back up here, and I'm going to stick with the micro, T2 micro. That's fine. Next, keypair login. Which key do I want to use? And I'm going to use the one we just used a second ago, ID RSA. Okay? Next, network settings. This is what I mentioned in terms of the security group. And we're just going to be really liberal and really generous with the security group to begin with. And then as we create these, we're going to kind of start to filter this down more and more. So I don't have any security groups yet. I haven't done this before. And so I want to create a security group. And I want to allow SSH traffic from anywhere for right now. And this little syntax, 0.0.0.0/0, this is what we call a CIDR block, and this is a notation that says anywhere on the internet, any single location of any other IP address on the internet can access this server over the SSH port. So we'll leave that okay for now. Configure storage, it suggests 8 gigs of GP3 type storage, general purpose solid state storage. That's fine by me. And then if you want to just peek at the advanced details, domains, IAM profiles, host names, auto recovery, shutdown behavior, so on and so on. Lots of rich options here. User data, here's where you can post user data. We'll use this later. But let's go ahead with no other settings and just go ahead and launch the instance. So there we go. It comes back to say, hey, successfully initiated the launch. Remember, it's put this request in a queue and now it's creating it. And I'm just going to click on the name of the instance. And it actually opens up a new tab. I don't want the whole second tab, but I'll just leave that there. And notice that it's filtered our view down to just one instance. Here's our instance ID. This is 16 characters long. It's in a pending state. It's a T2 micro. Here's its public address, its public IP, and so on. So I'll just refresh this a little bit. Hey, it's already running. Great. Now, if you click on it, you can see a lot of facts and details about the instance. So you can get its ID and you could copy that if you wanted. We'll grab its IP address in a second. It's in a running state. It has a host name given to it right now internally. It has a private internal IP address, which is right here as well, so that different servers of ours could talk to each other over these private addresses. It's in a VPC. It's in a subnet, which is an availability zone of the VPC. I could go up here and I could see status and alarms. It's running fine. It's passed all its status checks. So that just means it's running. It's doing okay. Here's a little bit of monitoring. Here's our security. We can see our inbound rules that we created. It automatically created a security group, and it allows port 22, which is our SSH port. It allows it from anywhere, which is great. Okay, and there's our security group name is LaunchWizard1. I can look at more networking. I can look at storage. Here's the one hard drive, and it's 8 gigs in size. All of these details are important at another time. What I want to do is I want to simply shell into this instance. And so I'm going to copy this address. Okay, and now using that address, I'm going to shift over to my terminal, and we're going to shell into this server. So this is the syntax for doing it. You're going to use the SSH program. So SSH is the command. And then we're going to identify ourselves using our key. And so the I is the identification option. And we're going to say it's in my SSH directory, ID RSA, So that's the first option. SSH is a program. The first option is I'm going to identify using this key, and then I'm going to sign in as a special user. And this is the default user for this type of instance, EC2 user at, and then I'm going to paste my IP address. That's basically it. And this should sort of look familiar, like an email address, really. It's user at host. And this is a common pattern on the internet. This is the way we connect, certainly an email address at, inmcgee@virginia.edu. SSH works the same way. You want to log in as this user at this host, and you're going to identify yourself using this flag, using this key, not a password. So once you've done that, you can go ahead and hit return. And each time you sign in using SSH, each time you sign into a new IP address, you're going to get this request one time that says, hey, the security fingerprint of this key that I'm using, I've never used it before. I've never encountered it. Do you want to continue connecting? Yes or no? And so you can just type yes. Every time you see this, for the sake of this class, you're fine to just type yes. In a high security context, you'd always want to check this out and verify it and so on. But we're just going to say yes, permanently added, and boom, we are suddenly in a server in Amazon in Northern Virginia. They've just added this this amazing, is it Eagle or Falcon or something like that. These are called ASCII art. ASCII art is always kind of cool to look at. So check it out. We are signed in as the EC2 user at this host, and I could type W to see who's logged in, and it's only us right there. I could type in uptime and see, oh, it's been up for 4 minutes. I could type top and see what processes are running. Here's a bunch of things, K workers running, migration, and so on. So, and I can see that I am the EC2 user in the /home directory. And this is the default user as set up by Amazon for this particular kind of server. And I actually have some superpowers here. I can do this very special command, sudo su. I can become the super user, which means I can become root. And if you issue that command, look, I'm suddenly in the root account. And if I cd to the home of the root, then where am I? I'm in /root. This is a really, really powerful way of moving inside of a computer. So you should be really careful with things you do. You can install and delete and control everything about the computer using the root account. There's nothing root cannot do. So use that wisely. We'll use that in a little bit, but let's go ahead and exit from that. And let's just go ahead and exit from the host itself, okay? And shift back to the console. So notice that test1, our little server, it didn't see, this is just an arbitrary name. Notice that it's running, and we can do something with this. With it selected, I can go up to instance state, and I could say, hey, I would like to stop this, or reboot it, or terminate it. And I think I would like to just terminate it. So let's do that. Terminate. Good. And that's it. It's gone. Completely gone. So I'm going to uncheck that, and I'm going to clear that filter now. And you'll see it's in a shutting down state, and pretty soon it'll be to a terminating state. So that's great. That's just what I wanted. So let's go back to instances and launch an instance again. Let's go through the whole thing one more time. Test 2. Okay. This time I'm going to change images. I'm going to use Ubuntu. And I like the 64-bit. I like the micro, the key pair. I'm going to use the same key pair. I can actually, let's just go ahead and create another security group, and let's be a little more secure this time. Allow SSH traffic from my IP address. And so this is my current IP, 216.126.35.162/32. And this is a way of saying this exact IP address and no other addresses are the only ones allowed to reach it. This 32 means there are no other available addresses besides this one that can talk to this server. Okay? I'm going to leave 8, and I'm going to leave the advanced details. Go ahead and launch the instance. It puts in the request. There it is, successfully initiated. It opens up the new tab again. It's in a pending state. And now every instance type, every AMI, tends to have its own default user. And so what we're going to do now is log in as the Ubuntu user, because Ubuntu is the default user for Ubuntu servers. And Ubuntu is a really common distribution. So let's copy this public address again. Let's come over here and remember the syntax. Just get really used to this. SSH-I. So there's the path to my key, relative path because I'm using my tilde here. And I'm going to sign in as Ubuntu at the host. Okay? SSH, identify with the key, Ubuntu user at the IP address. Sign in, I get the same request because this is a new IP. And I say, yes, I'm in. There we go. Now I'm in Ubuntu. Ubuntu 22.04 LTS means long-term support, which means this is probably good for another 2 years of support packages to keep it secure and fresh. And now I can say, W who's here, date, it knows the date. My uptime has been up 1 minute. Now I can sudo to su as well. If I clear that, I can see, I'm still I'm in the home Ubuntu directory. And now I'd like to show you a little something. So suddenly we've entered the realm of systems administration. You are now a systems administrator. And you might want to do something like update the software on the server. So you could say apt update. An APT is a package manager that's common to Ubuntu and Debian and things like that. There's also Yum, and we'll work with Yum in a minute. So apt update, let's run that. And this tells apt to go out and fetch the lists of all the newest software, everything that's out there that's built for Ubuntu 22.04. So it's going to fetch all of this. There it is. I can say, now I can run this command, apt list upgradable, to see what could be updated. And look, there's a lot of stuff that could be upgraded. And so I'll just say apt upgrade. And it's going to come up with a whole list. Following new packages will be installed. The following packages will be upgraded. Do you want to do this? It'll use this much space. Do you want to continue? Yes or no? I put in capital Y. Here we go. It's updating. It's going to configure things. It's going to install them and show my progress at the bottom. This is a really common task when you're a systems administrator. In the old days, we would shell into individual servers and do this one by one with like a checklist and just check off that we've done it. We do this process now with automation. We use tools that will automatically go out, and we could basically declare the state of our server fleet and just say, hey, everything should be current according to X and Y and Z. You go out and log into all of them and make sure they're all compliant. And that's a way of completely automating it and completely assuring yourself that everything has been updated, everything's running the same version of something, and so on. But this is nice to learn it by hand a little bit. So it's almost done. It's generating a boot image. That's one of the last steps it'll do here. And then it's going to exit out, and we're going to have like a completely updated Ubuntu host. Hang on one more second. Awesome. Okay. So new kernel is available. Restarting the system to load the kernel will not be handled automatically, so you might want to reboot. That's great. What services should be restarted? I'm going to select all the default things, and you use your tab key to go around with your options here and then hit return on OK. And that's it. We've updated all the packages. And now I can use apt to actually install things I want, like apt install git and apt install JQ. So I can do that. Do you want to install? It's going to use about a megabyte of space. Here's what it's going to install. Yes, yes, yes. That's great. And now clear. And now I know it works because JQ works and git works and so on. I have Python 3 already installed, so that's good. So we've now created a different kind of server. We've updated its software a little bit. We'll do that on a Red Hat in a second here. But it's a basic operation. You create the instance, you update the software, and you start installing things you need. Let's exit out of this one. So I type exit to leave my root account, and that leaves me into the Ubuntu account. And then I type exit again. Okay, so switching back over to the list of instances, you can see test 1 is still here. It's in a terminated state, and that's to be expected. This will go away in an hour or two. This line will just kind of dissolve away, but I think they want to show you that you've terminated something. Test 2 is still running, and it's a T2 micro, and I just want to show you a couple of things that are pretty important. One is I'll just stop the instance. Gives me a warning about that. So it's stopping it. And there are a couple of things going on here. One is, let's say the T2 micro was not quite the right instance type for my use case, and I needed maybe some more memory or some more CPU or something like that. I wait until it stops all the way, and I can just kind of refresh this. Clear out of my notifications here. Stopping. This usually takes about 20, 30 seconds or so. Stopped. Perfect. At this point now, if I needed to change that instance type, I leave it selected and I go to Actions. And at this point, I can change a lot of things about it. I could change the security groups it's in. I could change networking features about it and so on. But if I go to Instance Settings, I can change the instance type. And this basically just lets me type, or enter, let's say I wanted a C5, 9 extra large, or an 18 extra large, or an M3, or an M5. Any of those other types are possible. Here's a T2 Nano, which is even smaller than the micro that we're using currently. So this is where I would select it, and then I would just apply it. I'm not going to apply it right now, but if I applied it, then instantly you'd see it over here as being changed. And at that point, I'd select it again and say instance state start. So that's the first thing to realize, is that you can always stop it, change the instance type, start it back again, and you have a more or less powerful instance to work with more or less resources than before. Second is, you don't have to leave this running 24/7. You could use it for 30 minutes, and then you can just stop it and stop all charges from occurring. And then you come back 3 weeks later, you start it up again, and you begin working again, and so on. And so you can use that instance state as a way of turning it off, turning it on. And there's other ways to do that. There's even great command line ways to do that that are very, very easy to work with. So that's the second thing. And the third thing I want you to know is that, let's say test 2 is back up and running, and I want to sign into it again. And so I just use my up arrow key and I try to sign in. But you'll notice after a few seconds that this thing is just seeming to hang. It's not going anywhere. And that's because, I'm going to Control C to get out, and that's because this public address, in the very few seconds that this thing was turned off, this public address has already changed. So I need to copy the new address. I need to come up here, up arrows, and remove all this, and type this one in, and then suddenly I'm in a new address, but I'm back in my same server. And that's because these addresses that are assigned are from very large pools of random addresses that Amazon happens to own. This is just the same for GCP and Azure. And so it changes from time to time. Every time I turn it off and turn it on, it's likely to have a new address. The way around that is I can use what's called an elastic IP. And I can actually reserve, I'm not sure if the Learner Lab will let me, but I'll try it. And you try it with me. Allocate an elastic IP address. Everything here is good. Yes, I'll allocate that. We're going to make sure to delete this. So now let's select that IP. And here it is, this new address, 44, and it ends in 67. We're going to select it and say associate it. And it's going to ask us to type the instance in. There it is, test 2. That's the only thing I need. I can leave this option. I can leave this blank. I don't have to check this. And I associate. Then what we suddenly see when we go back to instances is test 2 is now at this new address. And this is a persistent address. This is the same from time to time to time. So if you're running a server that has a particular endpoint address, or you're shelling into this thing a lot, even though you're turning it on and off and so on, you would need to, yeah, see my screen froze because the address changed. So I say ssh-i ubuntu at, there we go. So now I'm back into the host. The one thing to keep in mind about these elastic IPs is if the instance is turned off, you get charged a few pennies a day for keeping this address while you're not using it. So that's a little bit of a thing. In fact, let's just walk all this back. I'm going to exit. I'm going to select this elastic IP. I'm going to release the address. Can't be released while it's still associated. So disassociate. That means detach it from my instance and release it. And now it's gone. And if I go back to my instances and I select test2, let's just terminate that. Gone. Okay. So now I'm going to have two terminated instances, test1, test2. Okay. Let's go ahead and create another. Let's create back to an Amazon type. So launch instances. We want 1, test3. Let's use the AWS Linux. Let's leave everything good there. The micro's fine. The key pair, we know this already. Maybe this one. Maybe I'll use the voc key, the VOC key, and I'll use the learner lab. Network settings. I'm going to allow it anywhere because the learner lab, I don't know the address of the learner lab, and so I want to shell from there. So I'll leave it anywhere this time. Storage is fine. Great. Launch the instance. So it puts that in the queue. We select it here. It's going to be pending. And so now if I go to the learner lab, you know, look, the identity is going to be a little different. So I'm going to clear this path, clear this screen. I think I need to refresh the page. This is in a pending state. Now it's running. So I'll select it and I'll get this IP address. Meanwhile, back over here, yeah, there we go. SSH-I. And now in my SSH directory over here, I have labuser.pem, which is just like, you know, over here, you know, I used my RDRSA on this, and that key is unique to my laptop here. This key is unique to this machine up here, and it is the one I selected when I built it. So what I can say is SSH-I lab user. And now remember again for Amazon Linux, it's EC2-user at, and I need to copy this address again, this public IP address. So I paste that in. It asks me, can I confirm that, yes or no? I do it, and there I am. I'm back in. So I've now shelled into a third instance. This one's running Amazon Linux. I shell in as the EC2 user. That's the default user. I can become sudo if I want, sudo. So this is the super doers operation to become the super user. And now I'm root. And now if I want to update stuff, I can use a package over here called yum. This is the package manager for CentOS, for Red Hat, and for Amazon Linux. It's called yum. Yum update. Hey, everything's complete. Everything's already been updated. That's great. So I can say, hey, yum install jq git, and let's just call it that. So this has a different format to it. It says, hey, if you want me to install these, here's the versions and everything. Here it would be 34 megs total from this 7.1 compressed. Do you want to do this? Yes or no? I hit it and it shows me the steps. It shows me everything that's installing. I now have Git. I now have JQ. We're going to work with JQ a little bit in the coming week or two, as you'll see. I can clear this. I can say yum, you know, install Python 3 pip. It might be installed already. Python 3 pip, and it's an encryption package that needs to come with it. That's great. Good, and I can invoke Python 3. And let's see if Bodo is not installed. So I can Control D out of that, and I can say Python 3 m pip install Bodo 3. And it's going to go out and grab the installers just like we did on our local machines. And now I open Python 3 and I say import Bodo 3. And now I have it. That's it. It's ready to go. So in other words, I can create this new instance. I can shell in. I can customize it and set up any software I want. And then I can stop this thing. I can stop the instance and come back tomorrow or 5 months from now, start it up again, and it will have exactly the same software. It'll actually be a little bit out of date, so you'd want to go ahead and yum update or apt update, depending on the instance you use, and catch up with any updates that have been released. Okay, so let's exit out of this, exit out of root, exit out of EC2 user. We're just back into our plain Learner Lab console. There is another option I can show you, which is called Hibernate. Let's see if this one is available to do it. I leave my instance selected. Yeah, there's not. Hibernate is not available for this. Some instance types can hibernate, which is pretty slick because it's almost like a laptop that you shut the lid of. It doesn't shut it down. It just sort of suspends everything exactly as it was. Everything's in memory just as it was. Any processes that we're running are just going to kind of freeze in time. And when you start it back up again, everything will resume as it was before. I'll have to dig into what you can hibernate and what you can't. But I'm hoping that you can see the ingredients for setting up an instance from the web console. What I'd like to do now is terminate this. Okay, so we've created and terminated 3 instances. Number 1 and 3 were Amazon Linux. Number 2 was an Ubuntu Linux. We won't go any crazier than that. But what I'd like to do is now shift to creating these using the command line. Just to show you really how pretty simple it is. Just like we set up the keys, the key pairs before, one thing that we'd like to set up before we use the command line to create an instance is maybe to use the GUI here, maybe use the web interface to create a security group. So on the left-hand side within EC2, scroll down to Network and Security, click into Security Groups, and you'll see there's one default there by automatically. But I'd like to create a new one. So click on that. It asks you to create the group name. You can say, CLI testing group. That's fine. That's convenient to me, but it doesn't matter to them. Allow SSH from my laptop. We'll just say that. Inbound rules, we need to add one. Add the rule. And it allows you to select things here, and you can scroll all the way down, or you can type SSH. And I'm going to say allow from my IP. And you can add a description. You can say this is my home IP address. That's fine. I could actually add other rules. I could add other SSH rules. I happen to know that 128.143.0.0/16 is UVA block 1, and there's another one, 199.111.0.0/16 is UVA block 2. There's actually a third block we won't worry about right now. But this means if I were anywhere on campus, in the dorms, in our classroom, wherever, I'll be able to SSH into this address. So you can add and customize these rules. It's all really great and useful. I'll just delete those and I'll keep my home IP. So that's good. I've got one inbound rule. I'll leave the outbound rules, which says all traffic headed outbound to any address is fine. And then I'll create the group. And notice that this has a unique ID to it. So let's just go ahead and clear, and I'm just going to write a note here. Security group, my computer's not going to recognize that, but I just have it preserved. So that's one piece of info I need. The next piece I need is an instance AMI. And so I'm going to actually go back to launch instances. I'm not going to use this all the way, but I'm going to select the Amazon Linux. And notice here in the details, the architecture, the boot mode, and so on, there is an AMI ID, and I want to copy that. Okay, so this way from the command line, I can create this exact sort of instance. So with that in hand, let me pull together exactly what the command will look like. It's deceptively short and simple. Hang on one second. So I've actually shifted things over to track the basic details we need for the basic ingredients we need. We've got a security group that we set up with the right access permissions. We've found the AMI ID for the Amazon Linux. The key name we know is ID RSA, the count is 1, and the instance type is T2 micro. So let's just assemble the command, and this would be in a basic AWS command. So AWS is the tool itself, and we're going to call the EC2 service. So the service always comes second, and then the subcommand is run instances. And then we need all of these parameters. So let's take them in order. Security group IDs, and we're just gonna paste that in. And it's plural IDs because you could actually attach several security groups to it at the same time if you wanted to. Let's see. Image ID is this value. Always starts with AMI. Good. Key name is, let's just go ahead and do 2. They'll be identical. Key name of 2. Sorry, that was ID RSA. Is the count I want to be 2. So just to be clear, the key name has to be ID RSA, which is a familiar key to me. And then the count I'll do at 2. And then the instance type is going to be a T2 micro. Okay, so this is this long command, but it's really only got it's only got 5 options to it. And I'm going to go ahead and issue that command. And what do I get back? I get back a long bit of JSON that says no groups involved, instances. And I've got a brace here as if it were an array. And that's because I do actually have an array. I have the first, based on this AMI, I have the first instance that ends in 23. And it gives me its address, its internal address. It gives me its external address here, private IP, public IP, and so on. Devices, what security group it's in, and so on. Then I come down and notice here are some brackets, and here is the next instance ID because I requested 2. So that's great. So I've created 2 instances, and if I shift over to instances here and just say running, then I've got these 2 instances that were just created from the command line. So I'm hoping you have 2 as well. They're T2 micros, so these are free for the Learner Lab. And now I could select one and get its public IP. And let's just shell into it for kicks and get used to this path. EC2 user. Cannot verify it. Do you want to connect? Yes. So we say yes to that. And we're in. So this is the 88.233 instance, which is right here. The private address is 88.233. So that's really quite useful. And now we can really run this thing. We can drive it from the command line. So let's say that we wanted to stop these, not terminate them, but just stop them. We could say AWS EC2 stop instances, and then it needs just one parameter, instance IDs. And I'm going to copy this ID. Sorry for the wrapping issue on my screen. It pasted incorrectly. Then I'll get this instance ID, and I'll issue that command. Here we go. First instance was in a running state. Now it's in a stopping state. Oops. Was in a running state is now in a stopping state. And if we come over here and refresh it and get rid of running, then we can see here's these two that are stopping now that we had just created. So let's recap. We've created, and you can ignore this last one that I had to create for a test real quick. We've created 3 by hand using the web console. We've created 2 from the command line, making use of a security group that we went ahead and created beforehand, and using a security key that we already had in place, and finding out the AMI ID that we needed to use to create it. The last thing I'd like to do, and then we'll move on to one final activity after this. Last thing I'd like to do is bootstrap an instance just a little bit. And to do that, we're going to use that user data field. And we'll go ahead and do this using the web console again. So let's launch an instance. And let's call this one Bootstrap. And we'll do it using Ubuntu, just to keep things mixed up a little bit here. We're going to do one of them. We will use the ID RSA, or whichever key you want to use, it doesn't matter. And then scroll all the way down. We won't worry about the security group this time either. All the way down and open up advanced details and go all the way to the bottom. And now we want to run some commands. Apt update, and we're going to say -y. And the -y means yes, accept anything, any requests you have, just say yes to them. That's basically what it means. And then we're going to say apt install get JQ, and we're going to say y to that as well. We could even say, Python 3 pip or Python 3 dev. Okay, and now it's really good because we're root and we have the power to install these, but it's running independently from us. It's really a much better practice to use the full path to this, and I do believe it's going to be user bin apt, although I'm looking if I have my slides up from earlier. If it's not the right path, then that would fail. So I don't know. We'll just go ahead and try it without a full path for each command here. I'm going to launch this instance. And what should happen is this instance is being created. So it's provisioning right now and finding some piece of actual real world hardware to go run on. And then the moment that it sort of comes online, only at the very last step of everything as it's created, only then does that sort of user data get initiated, that very first time that it's created. And at that point, it starts running those scripts. And if we're quick about it here, so yeah, it's running. And if we're quick, we can actually kind of go peek in and see those working. So I've got the public IP, I shift over, I say SSH-I, Ubuntu is our operating system here, so that's the user. Do I accept that? Yes, I do. Clear, ls, I'm going to expand this all the way. And now, if we say ps, I'm going to sudo to su, ps aux grep, I'm going to grep something and I'm going to say, hey, do we have any apt processes going on right now? No, we do not. Let's see if we have JQ. So the bootstrapping did not work, which means we need to find out where apt is. So we say which apt. It's in user bin apt like I thought it was. Okay, so no big deal. We'll exit this, we'll exit that. We're going to terminate this instance. We're going to try it one more time. Okay, so now Bootstrap 2, Ubuntu Linux, instant type, everything's fine. Select a key. We scroll all the way down, advanced details, scroll to the bottom. And I did forget a shebang line here. And I'm going to say user bin apt update y user bin apt install jq git python 3 pip python 3 dev -y. I'm going to do one final thing. I'm going to add in Nginx. Nginx is a lightweight web server. It was developed by Yahoo back in the day, and it's super fast. And it's going to give us one other final example. So let's launch that instance. And while we wait on that to launch, go back to EC2, go back to your security groups. Let's find the one that we used. Let's see which would actually be the most recent launch wizard. It was just created. In the inbound rules, I believe it's allowing from the whole internet. Yep. Let's create one more. Let's edit those rules and create one more. Add rule. And at this point, we want to scroll and go to HTTP. We want to allow HTTP from anywhere. Okay. HTTP is port 80 from anywhere, which should look like this. And we're going to save those rules. And that way, we're going to allow traffic into port 80 to see Nginx from this server that we just created. So now we go back to instances. We can see Bootstrap 2. Or if you want to filter it down, you can say running. Let's look at just running. So there it is running. We'll select it. We'll grab that IP. We're going to clear our screen. We're going to do the same command we've been doing. Ubuntu at the host. Yes. Good. And now we're going to sudo to su psaux grep apt. And you don't have to do this necessarily, but it might be good. I'm looking at all the current processes. I'm looking at certain values out of the current process state. And what I can see is that apt install jq, python pip, python dev, nginx, and so on are still going on. So I've tried to filter all the processes for the apt command, and there we go. And this is the current command I'm running. This is the Bootstrap command that is still in process. And if I run it again, or again, you can notice it's gone now, which means that command has already completed, or it errored out or something. But the way we'll know if this is there is, do I have Git? Yes, I do. Do I have Nginx running? I do. There's Nginx master and worker processes are running, which means if I run netstat, which is a stats on the networking, I can see, it's not there, so I can install it. Apt install net tools. Say yes to this. Yes, that's all fine. You don't have to follow along with this, you guys. You can just watch. If I now say netstat alt, I can see what is this server listening for. And here's one value. In IP4, it's listening for web connections. In IPv6, it's listening for web connections as well. And the cool result of all this is that I can take this IP address, I can open a new tab, and I can just go to my new little website, which should be right there. Welcome to Nginx. This is the demo page. So our final case here, going back to the GUI, we created an instance with some bootstrapping added in the user data section that added some software. It added Nginx and Git and JQ and some Python stuff. Installed it all for us that very first time it was created. And then finally, after we modified the security group, allowed this web server that's running on it to be visible to the world. Okay, I'm going to pause here, and I'm going to have one more activity for you to do. Hang on. Okay, so for the last little bit here, let's recap. We've created several instances using the AWS Management Console, using the Web Console. We've bootstrapped, we've changed the instance type, we've stopped things, we've restarted them, we've terminated them, and so on. We did a couple from the command line as well. You could actually use the same parameters to do that in Python using Bodo 3. It's really essentially the same thing. It's the run instances method. Needs to know an AMI, needs to know a security group, needs to know a key name, and so on. The last way I'd like us to build an instance, and this will be really easy for you, it's just kind of clicking and watching mostly, is to use a CloudFormation template. And we write these in something called a stack because it creates several resources all at the same time that are all sort of correlated within one stack, given one stack name. And so you can manage the whole stack, you could delete the whole stack, or you could create it. And we'll create this in just a second using this button. So if we want to look at the template again, we saw this in class on Tuesday. We have parameters where I'm asking the user for some parameters because they're going to run this in their account. So what instance type do you want? What is a key pair that you have that you want to use? What's your SSH location? I add UVA's campus addresses already. It creates a EC2 instance. So here's the instance type that the user selected. It's got the security group that it's going to create, and it's going to associate that, and the key name and the image ID. This is for Ubuntu Linux. It's going to give it a name, DS2002 EC2 instance. And it's even going to bootstrap it. It's going to run some apt update and apt install commands for us. It's going to run a pip command for us. It's going to add a second hard drive, 20 gigs in volume. It's going to attach it. It's going to create a security group. So here's that SSH location from the user. Here's the campus block 1, campus block 2, and then the web. It'll open it up port 80 to the world. It's going to create an elastic IP address that's sticky or permanent, and it's going to associate that with the instance. And then it's just going to output two things for me. What's the instance ID, and what's the IP address of the new server? And if you go back, and I'll zoom back out a little bit here, I've created a long special URL so that if you click on this, it actually throws this file against a service called CloudFormation. And it's kind of ready to run this file for us. This is just automatically in one click. It's given a default name already. It's asking my parameters, so instance type, the key name, I'll just go ahead and say ID RSA. Wants to know my SSH location. So let's just open up a tab. What is my IP address? And lots of services have this. I'll just copy this address and close that. And I'll just type in 216.126.35.162/32. This is my IP, and the /32 means that IP and only that IP. So that's all looking good. Let's create the stack now. And it just throws me right into it. And if I get rid of this and slide this over, and we look at the events pane and keep refreshing this, you'll see it's creating things. It's creating here's the whole stack name itself, creating the IP address, creating the security group, and it kind of goes through a status of each one and gives us a little update when things are completed. Another great way to view it is kind of by the resources. You can see what it's creating in what order. So it's already done with the elastic IP. It's already done with the security group. And this might take, I'd say, about 2 minutes to complete. So I'll keep this going, and I'll shorten the video here to kind of pass through the next minute or two of time. Okay, so I'm seeing 6 resources have been created. If I go to events, I see now the stack name itself is completed. I can go to outputs, and there's my 2 outputs, the instance ID and the IP address. And so if I copy that IP and I go to my terminal and I clear it, and I've got kind of a special path at the moment. I've got a special teaching folder here, and I just say Ubuntu at that host. Oops, I've got some tildes in there and a little extra character. So at 3.214.94.135, do I accept? Yes, I do. And I see that my system is up and running. And I've got JQ installed. No, I don't. Maybe I didn't install. I think I've got Git. Yes, I've got Git installed. I've got Python 3 installed. I can import Bodo. That's all really good. So that means everything bootstrapped properly. And what's cool is if I go back over to instances and I refresh here, here is my instance named as I want it with the Elastic IP address attached. So I can slide this up. Here's this permanent IP. And the server is completely usable. And I could use this, you and I could share this code, and we could pop out 50 of these, and they're all going to be exactly identical. We could slowly iterate on that code and maybe bootstrap it a little more carefully, keep things current and updated. But here's the really great feature, is once we're done using it, you know, we could start and stop this and use it whenever we want to, come back 8 months later, and so on. But once we're kind of done with the whole bit, from any of these panes, we can say delete the stack for me. And once we do that, then the events start to roll back. And now all the creation is all going to become a process of deletion. And you'll see deletion complete, and this entire stack is going to go away entirely. So that's a pretty useful feature. I'm going to be giving you some CloudFormation templates to use for projects later in the semester. It's things that have software pre-provisioned in them, things that are automatically ready to go for you so that you won't have to worry about doing all of those steps. But I do think it's important you create some using the GUI and the command line, and at least pop out one version of this instance using this stack. Okay, last little bit, just some housekeeping before we get out of here, is we should see that this is shutting down, so that's good. You can go down and look at your Elastic IPs and make sure they are all gone. That's good. That has no cost implications. Security groups, these are going to go away. This one will get deleted by the CloudFormation template being deleted. We can delete these two if we'd like. So we just say delete security groups. It asks me to confirm that. That's good. And then finally, we'll just look up here at instances and see anything that's there should be just in a terminated state, and they'll all go away again in the next hour or two. So that's it. That's using CloudFormation to build an instance with a consistent, identical footprint every single time. Okay, you've got a lab that I'm giving you. It's an optional lab for EC2 for this week. So go ahead and follow those steps if you'd like to, but again, it's optional. Have a great spring break. See you guys.